The formation of the heart tube is a critical step in early embryonic development, laying the foundation for the fully functional heart. This process begins early in the third week of gestation and is essential for establishing the circulatory system. In this video, we'll explore the stages of heart tube formation, from the initial development of the cardiogenic field to the complex process of cardiac looping and chamber formation. During the third week of development, gastrulation leads to the formation of three germ layers: ectoderm, mesoderm, and endoderm. The heart develops primarily from the lateral mesoderm. Cells from the lateral mesoderm migrate towards the head of the embryo, forming the cardiogenic area, a horseshoe-shaped region where the heart will begin to develop. Within the cardiogenic area, cells differentiate to form the primary heart field, PCHEF, which will give rise to the future atria, left ventricle, and part of the right ventricle. As the embryo undergoes lateral folding, the two sides of the cardiogenic field move towards the midline. This folding results in the formation of two endocardial tubes. As the folding continues, these tubes fuse to form a single primitive heart tube around day 21 to 22 of development. The paired endocardial tubes fuse along the midline, creating a single, continuous heart tube. The heart tube consists of three layers: the endocardium, inner lining, myocardium, muscular layer, and epicardium, outer covering. The heart tube differentiates into several regions, each destined to become specific parts of the mature heart. These regions include the sinus venosus, primitive atrium, primitive ventricle, bulbus cordus, and truncus arteriosus. The sinus venosus contributes to the atria and the superior and inferior vena cavae. The primitive atrium becomes the atria, the primitive ventricle forms the left ventricle, the bulbus cordus contributes to the right ventricle, and the truncus arteriosus will divide into the aorta and pulmonary artery. Around day 23 to 28, the heart tube undergoes cardiac looping, bending, and folding to the right. This process, known as dextrolooping or delooping, positions the future heart chambers in their correct anatomical locations. During looping, the primitive atrium moves dorsally and cranially, positioning itself above the ventricles, while the primitive ventricle and bulbus cordus move anteriorly and caudally. After looping, the heart tube begins to develop septa, which will divide it into four chambers: the right and left atria and the right and left ventricles. This process also involves forming the atrioventricular valves and the division of the outflow tract into the aorta and pulmonary artery. The formation of the heart tube is a fundamental process in embryonic development. It begins with the establishment of the cardiogenic field and progresses through the fusion of endocardial tubes, formation of a primitive heart tube, and its segmentation into distinct regions. The subsequent cardiac looping and septation transform this simple tube into a complex, four-chambered heart. Understanding these early events is crucial for recognizing how congenital heart defects arise and for developing strategies to diagnose and treat these conditions. Thank you for watching.